Good afternoon. My name is John Petrin, Town Manager, Town of Ashland, and welcome to Town Manager's Corner. Today is Wednesday, August 11th, 2010, and we're going to be talking about public works and energy today. We've recently received money and implemented new programs here through grants through the stimulus project. Everybody hears about stimulus project and federal funds. Today we're going to talk about how it's actually affected the town of Ashland. And we have several guests today on our program. I'll start to my left. We have Roy Correa, who is the General Foreman in Water and Sewer for the Ashland Department of Public Works. Doug Small, everybody knows Douglas. He is the Director of DPW and former high school standout star here, a clocker and all that. Band member, you know, a band, wow. We're going to check on that one someday. That's interesting. And Ted Gifford is a special guest today who was involved with the installation of our solar panels here at the Public Works Garage. Martin Shapiro, a standby always on our show. Mark Purple, Assistant Town Manager, and Matt Moran with Florence Electric, who represents the company, who assisted again with the installation of our solar panels. So, going to kind of turn this over. We'll start with Doug here and talk about the stimulus program and what occurred here in Ashland and what we got, you know, from the feds through the state.
Okay. Basically, we ended up doing two projects. One is here at the facility here at the DPW, where we installed solar panels, and the second one is at our water treatment plant, where we installed variable speed drives. The reason why Ashland was picked as one of the participants in this federal program was back in 2008. The state approached Ashland to see if we wanted to do a study on how to save energy, basically at the water treatment plant. So basically what happened is Roy Correa and Woodard and Curran got together and they put together all the paperwork and submitted everything. At the time, there was no such thing as this federal stimulus program back in 2008, of course. Ashland properly did its homework along with 13 other cities and towns in the state of Mass, and we were fortunate to be one of the 14 chosen for one of the first allotments of this federal stimulus funding. So that's pretty much where we're at right now. Both jobs have been completed, and we're hoping to see some substantial savings down the road, and that's where I'm at right now.
So what we did is two parts to the program. The first was a solar array here at Public Works Garage, and we were able to get that because our water department is housed here in the Public Works Garage, and it was a better project to do here than at the water treatment plant, which is where we looked at it first. And then, of course, the second part is at the water treatment plant, where we go through a little bit of electricity in running all those pumps, and by putting in the variable speed pumps versus the fixed speed, we have a savings in that. So I guess at this point what I'd like to do is turn to Ted with Woodard and Curran. Now, Woodard and Curran is our plant operator. So we have a water treatment plant, but we found it best, I think about 6 years ago, we went to an outside consultant to operate the plant because they bring the expertise. They run many plants here in New England. Many communities use them, and private companies for running plants. And so we hire an outside firm to actually operate the water treatment plant because it's a better way of doing business. They have central people from scientists on board to analyze the water, to engineers and electrical people and so on. So Ted brings that view in the operation. So maybe you can talk about how Ashland was ripe for this type of project.
Yes, the Ashland wastewater treatment system has a variety of pumps in it. Pumps can be turned on or off and use the entire load of the pump. And during an evaluation such as we did, we evaluated that if we could use a variable frequency drive or VFD component to these pumps, then we could ramp the pump on and off and not use as much power when it's not needed to be completely on. So that was an enhancement to the wastewater treatment plant. Here at the DPW, we had a a photovoltaic system or PV system where we designed and had installed about 120 different panels, all being fed to converters, as you see in back of us. That converts that DC power to AC power, and either it gets used by the building here or gets pumped back out onto the grid in the form of power that is used in other places. So that's the genesis of those two projects and what they hope to produce. Right now we're running about 19 kilowatts of power in back of us, and that's being either used by the building or put out on the grid as needed.
So we have basically the Selectria renewables here, and so we have the solar panels on the roof.
Yes.
And this is the, so these are the governing section, and gives us, basically telling us right now we have an EAC of 1661 kilowatts on this upper unit, and a PAC of 9746 watts.
Watts or 9.7 kilowatts.
Okay. So what's that telling us at this point?
It's telling us that there are, of the two arrays, which basically an array is made up of several different photovoltaic panels, that array is producing about 9.8 kilowatts of power. The second reading, the EAC, is the amount of kilowatt hours over a given time that it's producing. So it's basically a power over time reading that we're taking here.
So right now, are we producing our own power for this building? Is this?
So if we go over to the meter over here, which is measuring whether we're taking in or producing out power, it is reading. Let's see.
24. Just went out, resetting itself there.
Well, it goes through a series of readings. So It's let me go through. There are. Okay, so right now we're basically using the power here at the building. As it produces more power or the building uses less, it'll start to produce the power back out on the grid. Okay.
So pretty interesting. Mark, why don't you talk a little bit about the finances?
So this project was about $486,000 in stimulus funding, and originally the project was designed to support solely photovoltaic improvements. And when we took a look at the potential savings of what they were going to put up on the roof, the savings weren't as great. So we took a look at other ways to use the funding, and we said, why don't we try and shift some of the money to putting in variable speed drives on the pumps at the water filtration plant. That would help us to maximize the savings. And we took a look at it, increased our savings. The savings from the variable speed drives are probably in the ballpark of about $70,000 a year. Those were the estimates. And here it's, Nexamp can provide better figures, but I think it's in the vicinity of about $2,000 to $4,000 a year in savings. So we made the application to the state. The state said we'll agree to do that. So we put a smaller photovoltaic plant and put in the drives on the pumps, which essentially gave us more savings, and that's how we presented it to town meeting, and that was what was approved. So what was approved is what was done, and be able to tell, hopefully in the next several months, now that everything is up and running, how those savings are actually doing for us.
So this is great for the town of Ashland because the funds for the infrastructure, which is always the problem for these type projects, was provided from federal funds through the state. So this was a program which I give a lot of credit and commendations to Mark, Doug, and Roy, because those three were the team that put together our application and stuck on this. This wasn't a one-week project in preparing the paperwork and getting in. This was a long time in the planning stage so that we could get these funds available to the town. So this is the type of work that gets done in the background with grant writing and, you know, done by our team. As people know, we don't have a grant writer on staff, and so a lot of grants are done in-house by folks, you know, who are here doing the work. So Matt, what was your role in the project here with Florence?
Installing the solar panels up on the roof, installing the inverters here.
So were you here on site for this project?
Yep, that was.
So when did we install the panels? That was this spring?
That was in May.
Okay. Was it a typical project for you guys?
Yeah, we've been getting into it past year or so. We've been doing more and more solar panel projects.
Have you done any of these other state projects, or are you doing a lot of private
yes,
work?
We've got a lot of state projects coming up, still to be done, but we still got a few to go.
So were we one of the first ones, you know, off this stimulus project?
You were the first one off the stimulus project.
So we were the first. So
Yeah,
we're ahead of the
Yep.
curve here, and Ashland became a first. And did you learn anything out of this project that you would do differently?
You know, yeah, there was a couple of things that were that we did different here than we haven't done before, but nothing major. It's
Yeah.
after a while it becomes routine.
So how did we get the first to the line to get done?
To be honest with you, that's all above my head. I couldn't.
Another pay grade. It was
We were one of the smaller projects.
right. So we were a smaller project on
It
this,
was
so
one
one of the
easier
smaller
ones.
communities.
It was quicker to do the permitting.
And I also understand, you know, with Roy's assistance and Doug's assistance, a lot of the
Right.
work got done easier here, and
Right.
you know, we were a good people to work with. You know, is what I've been
And
told
one of
behind the scenes.
Some of the larger projects in Marlboro and Worcester and things of that nature, and that there's a lot more MWRAs involved and things like that. So this was a lot easier to handle. So they wanted to get one done and move forward, and so yeah, we were.
So
one
this
of
was
the
a good
first.
project for them to,
Absolutely.
you know, take a hold of. Roy, how fun was it?
Actually, I learned a lot from this project about solar panels. I worked with these guys, I mean, behind the scenes, helping them out, just making sure they had what they needed, they're prepped. I got to go on the roof, see how they did it. They showed us how they could be lifted, moved easily enough for repairs. They explained these panels, how they work. It was really interesting. I
Yeah.
learned a lot about solar energy. Compared to 20 years ago, I'm more impressed now, you know. So, and a lot of the guys were interested in it, so there was a lot of questions from the guys too. Good crew to work with. These guys were very efficient. They did their job very well. So it was a pleasure to work with everybody here.
So are all our pumps now, let me just switch topics a little bit. We're talking a lot about, you know, the solar panel here in the array, and, you know, the fact that we're capturing a lot of our own electricity here now and are able to, once in a while, to put it into the grid and make some money that way, putting it into the grid. So we're producing more, you know, at some points. So where are we on the variable pumps? Are those all installed at this point?
We have 5 wells, and all 5 wells have variable speed drives that have been installed. We also have the pumps that feed the water to Ashland and to Hopkinton, and variable speed frequency drives have been installed in those as well.
So how many pumps or drives did we?
I think the total was around 10.
Okay, so we replaced them all.
Yes.
And that was a good project because we would have had to replace those drives at some point in the life, because drives aren't permanent pieces of the fixture, and so
Correct.
that would have been, so that's a capital we saved
Right.
in the future by having these drives replaced by the state funds
And improve the
that-
technology.
and improve the technology and cut our electricity
They're going
costs.
to last a lot longer too, because the wear and tear is going to be a big difference on wear and tear. Those big startups, you know, that wear the motors right out, the life expectancy should be a lot better on those motors. And not just energy savings, but you're talking long-range maintenance
You're right.
on those motors. It's going to be a big savings all around.
Ted might be able to help me out on this, but from what I understand with these variable frequency drives, what we had before we installed them was if we turned the pumps on, the water went bang. It just went through at 100%, and we control it by putting a gate up, closing a gate up or down or whatever. What this variable speed drive does, from what I understand, is we're able to ramp it up and use less energy.
That's correct. With the old system, you would have gotten a full-on all at once, and the possibility of water hammer down through your piping system is definitely there, which can weaken your pipes and so forth. With the variable frequency drive, being able to ramp it in, it's a slower start, and a slower ramp up of the water into your system as well. So it's not only better from a maintenance standpoint and longevity of the equipment for the motor and drive, but also the piping system downstream.
So the drives that we had in place, were they original for the most part?
Yeah, they were from when the plant was rebuilt, the new plant, what was it, 8 years ago? So
Yeah,
they were original.
Yeah, we put 2 new wells on in 2003, Mark, right? And so we have 5 up there. The other 3, they were probably existing from years prior to that. So all 5 have been upgraded since.
Yeah.
And how long would a drive last?
Depends on the usage,
Right.
you know, I mean, it's all about wear and tear and general maintenance, how much it could last you 10 years, could last you 20, could last you forever, but there's always, as you get the wear and tear, they work a little less efficient too. So, I mean, they'll work, but they're always going to be less efficient. With the ramping, it's going to be a nice smooth transition. You're going to get a lot more time out of them, and you're going to get less general maintenance. So,
Yeah, but the regular pumps, the wear and tear that we're putting on them up there at the plant,
oh, those,
everything,
yeah,
10 years?
yeah, probably 10 years, I would say, yeah. I mean,
So this
even
was
with
great
general-
timing for
even
us
with
because
general
we were
maintenance,
approaching,
Yes.
you know,
Yeah.
10 years on a
Yeah.
lot of these pumps.
Yeah.
You know, between that plant went online, basically, what, 2003 maybe?
2003.
And then you had portions, you know, that were online prior to. So the drives that are in the plant came on in '03, and then the drives that are at the wells, you know, have been in place. So this was a great opportunity to replace
Great
those
timing,
drives.
Great timing. We would have, in a year or two, we would have had to replace them anyway, most likely.
Yeah.
You know, it would have, and they're costly. So now you're going to get a lot more life out of them.
Right.
Absolutely.
So what we have here is not just the savings in electricity, but this was great timing for us because what would a drive cost? I mean, what did it cost for these drives?
I think it was 100 and...
Let's say
Yeah, the
that-
total project for the plant was close to 200,000, wasn't it? 160.
So
to
It
200.
was about
so-
$200,000 for the pumps.
For the pumps, for everything.
drives and everything.
So that's money we potentially would have been spending
Sure.
2, 3, 5 years
Could even
down
been
the
more
road.
Down the road.
Right, so exactly.
Because they never go when you want them to.
Right,
So.
and it's always as an emergency basis. So this was not just an opportunity to better our electricity, but it was basically a great capital, you know, outflow, you know, timing-wise, because we changed things we would have been changing in the next few years.
And beyond that, John, it created work. It put people to work here at the DPW and also.
Boy, the state gonna be proud of you, Doug. That was
And we used to-
great. Yeah, look that one up.
Cue card over there.
It created, it
Think
created-
big, vote small.
My God.
He's got, oh God.
He's waiting.
If he's running for something. Yeah, and we've got our sign, you know, up here, the recovery.com. So the project's funded by the American Recovery and Reinvestment Act, ARA, as most people know. So obviously this is funded through that project, and Doug makes, you know, a great point. That was the whole piece behind it. And from what I understand, you know, we've got a couple people who had work opportunity by having these installed. It didn't create jobs for, you know, the town of Ashland, but it gave us savings and created temporary, you know, opportunities out there for other companies to work under the ARA program. So Doug's absolutely right on that. I just want to point out that
One requirement of the ERA funding, if people don't know, is that the equipment that is being bought has to be manufactured in the United States.
Oh, okay.
So it's actually not only jobs here at the facility, but also in the manufacturing plants that manufacture the equipment.
So it's the big loop,
Right.
you know, that we're looking at here, that, you know, everything comes through, and it's an opportunity to keep the green. You know, Massachusetts, of course, is looking to have, you know, you know, the inroads with green opportunities, you know, with companies and so on. And so this was a great opportunity for us to, you know, keep some of that going.
Sure.
Having Massachusetts firms, you know, install it, but maybe some of this equipment came from, you know, Massachusetts R&D and so on.
It all sounds good to me. I especially like Doug's explanation of why to use the variable pump motors. I was wondering what on earth, what kind of savings you got out of it. Now I can see it's plain as the nose on my face, I guess.
Yeah, and it really is on the electricity side, you know, so you know, you're not running at full speed all the time. And I guess, the numbers showed there is great savings, and that's how we were able to get the grant, by producing all this, behind the scenes numbers and putting that together. So this is a great opportunity for the town of Ashland. And what's happening today actually is that we do have Jeff Simon, who is the director of Mass Recovery, coming out here to review these projects. So that's kind of what created the topic for today's Town Manager's Corner, was having him coming out, to see and to showcase Ashland in this case. So he'll be out here this afternoon to review all this.
Okay, so we're back up here on the roof at the Public Works facility at Ponderosa. Again, I'm Mark Purple, Assistant Town Manager, and this is Roy Carrera, who is the General Foreman for Water and Sewer for the Department of Public Works. I'm also joined by Eric Aubrey and Emily Dahl from Nexamp, and they were the company that did the installation up here, so they can talk a little bit more about this. Just wanted to give people an idea of what they're actually seeing in that. So, Eric, tell me a little bit about what we're seeing, what we've got up here, and in the process that we went through to get it up here.
All right. So what we installed here is 120 solar panel modules, which produces approximately about 24.6 kilowatts. So what ends up happening is we've installed the 120 modules up here. We run them over to our combiner boxes, which picks up all the modules, which in turn runs down to our inverter, which converts our DC power, which is what we get from the sun and solar power,
right,
into an AC power which the building can use.
Okay.
So we tie into your active system at the inverter, go in with our DC power, come out with our AC, and power up your building and your facility here.
Okay. And this is we talked a little bit about this earlier during the first part of the segment about this is the first project that was completed.
Yes.
Under the stimulus and
Yep,
up and running.
Yep, the first one up and running. First
Yep.
one turned on.
So that's great. So how many panels?
120.
120 panels. Okay. And we feel that now it's 24.6 kilowatts, and that.
Right.
What are the chances that we get up to that level of the 24.6? Based on the way that the array is facing and.
Oh, I think I think you'll meet that pretty much most of the high peaks point of the day. You will end up meeting that.
Okay.
Because actually these sometimes what the modules are is actually rated for at least that. So you should be able to meet that demand or that load. So.
Excellent. Okay, so Emily, Eric has kind of explained what we have up here and everything in that, but a lot of people don't understand, with the kilowatts and the conversion and the transfers and what that all means. Can you break it down a little bit so that, the average person out there, can understand, as a homeowner, what, this type of energy creation means?
Sure. So as you can tell, this solar array is a lot larger than what the average homeowner or the average home would use. This array is actually large enough to power about 10 homes. And what that means for this facility is that it's powering about 40% of the facility's electricity needs. The cool thing about this project is that it's one of the 12 facilities funded through the American Recovery and Reinvestment Act of 2009.
It's a mouthful.
Yeah, it really is. But a great program for Massachusetts, because this combined with the other 11 will power about 600 homes a year, which is pretty cool.
Right, and this is one of the smaller projects, and my understanding is that was why that we were able to get this off the ground as quickly as we were, and and I know Eric was happy, to put wraps on this. The permitting went fairly straightforward. What is the next project that you've got in line that is coming close to completion?
Well, I think Eric can talk about that. I know that we've got a really big ground-mounted system in Chelmsford that's it's plenty bigger than this. It's about 485 kilowatts, so powering a few more homes than this one. But these projects are all important because they're all powering facilities of different sizes and meeting electricity needs with clean power, which is great.
Absolutely, absolutely. So I think that this gives us a good idea of visually, what the ARRA funds were able to do for us in terms of the solar. We already talked about the variable speed drives for the pumps up at the treatment plant. on Howe Street. So now that everyone has an idea of what what we've been able to do, and hopefully the savings that we'll be able to generate from this, I think that pretty much concludes our visit up to the rooftop of Public Works Building in Ponderosa. So again, I'm Mark Purple, Assistant Town Manager, and thank the guests for coming up with me, and we'll see you all next time.
So I think that concludes today's Town Manager's Corner. And again, today's Wednesday, August 11th, 2010. I want to thank all my guests for being on today's show. So that's it, and we'll see you next time.